You ever record something and it comes out really good, and you just wish you could turn it into a 3D scene, add objects into it, build VFX shots around it? But normally doing that in Blender takes hours, sometimes even days, modeling and texturing objects to match the scene. But what if you didn't have to do any of that? What if you could take that video and turn it into something you can actually work with in 3D? Same scene, just in 3D. In this video, I'll show you how I transformed a video I shot and turned it into a fully explorable 3D scene, where we can add 3D objects to our scene without the need of camera tracking, using Gaussian Splatting. Before watching this lesson, please make sure to subscribe to my channel and hit the notification button or else.
This lesson could be your very last.
So the first thing I did was record the scene I wanted to turn into 3D. Then I brought it into Blender. And with the help of a free open source add-on, I was able to convert that footage into a fully explorable 3D environment. In this video, I'll show you exactly how I went from a real video to a 3D scene. Now, to get started, you'll need a few things. You'll need the SkySplat add-on, the 3DGS add-on, and Colmap. Colmap is a reconstruction tool that takes images or video frames and rebuilds them into a 3D scene. I'll leave links in the description so you can download everything. Now, when it comes to Colmap, you'll see two versions. If you have an NVIDIA GPU, go with the CUDA version, it's faster. If not, just use the non-CUDA version. Once you've downloaded everything, go ahead and install the add-ons in Blender. Just drag and drop the SkySplat and 3DGS files into Blender and follow the prompts. For Colmap, extract the folder you downloaded and place it somewhere easy to access. We'll come back to it in a bit. So once you've installed it, you should find it in the end panel. Now in my case, I'm using the Simple Tabs add-on, which lets me organize everything into a single tab. So it doesn't clutter up the workspace, it just makes things a lot cleaner and easier to navigate. So right here, I've got both add-ons in one place, SkySplat and the 3DGS add-on. If you want to set this up for yourself, I've got a full video showing how to customize your end panel and keep things organized. You can check that out using the link on your screen. Alright, so inside SkySplat, click on the SkySplat Video Loader dropdown, then hit the plus icon to add a new video instance. Under Video File, click the folder icon and import your footage. Once that's in, go ahead and click Load Video and SRT. Give it a second to process and you'll see it suggests a frame step. This is basically how many frames it skips, so it can process things faster. Now we're going to extract the frames. So click Extract Frames, SkySplat by default extract those frames, and place it beside the original video. Once it's done, the folder might open up, you can close it and continue. Next, we move over to Structure from Motion. So here in the Colmap settings, you want to point this directory to where you extracted Colmap earlier. Just navigate to that folder and on Windows, select colmap.exe. If you're on a MacBook, open your Colmap folder and select the Colmap application file. Once that's set, go ahead and click Run Colmap to start the process. Now this should take some time, so just let it run. After 806.52 seconds, we get a message saying Colmap processing completed successfully. What Colmap did behind the hood is analyze all those frames we extracted and reconstruct the scene in 3D. You'll notice a bunch of points appear when you load the Colmap model. That's called a point cloud. It's basically a rough version of your scene built from all the camera angles in your video. At the same time, it's also figuring out where the camera was, how it was moving, and even the lens settings like the focal length. It's rebuilding the exact camera setup from your footage. And all of this is what the next step uses to generate the final 3D result. So once Colmap is finished and your model is loaded, the next step is to export the transformed model. After that, we'll prepare the dataset for training. Now from here, head over to the Gaussian Splatting section and click on Run Training. Once you do that, this window will pop up, and this basically shows you the training progress in real time. At the top, you can see the scene gradually being reconstructed, and below that is the reference image it's trying to match. As the training continues, you'll notice the result gets sharper and more detailed. You can also keep track of the training steps. The higher the steps, the better the quality. And over here, you can see how much time has passed. Now for reference, I'm using an NVIDIA GeForce RTX 4060, so performance is pretty solid for this kind of task. But depending on your system, this might take a bit longer. So at this point, just let it run and give it some time. So at this point, you can pause the training. I stopped mine at around 11 minutes, but you can let it run for an hour or more. The longer it trains, the better the result. Once you're ready, you can pause the training and then proceed to export. Now we'll move over to the 3DGS add-on. In here, enable Create Proxy Object. Then click Import PLY and load your trained result. Now under HQ and LQ modes, meaning high quality and low quality, enable HQ Object Overlap. Switch to HQ mode Blended Alpha, and then click Generate HQ Object. Once that's done, if you check your outliner, you'll see both the high quality and low quality versions. By default, the low quality one is hidden in the viewport, so you'll mostly be working with the high quality version. Now under Update mode, you'll see three options. If you don't see them, make sure you've selected the exported object in your outliner. First, we have Point Cloud. This is a simplified version of the scene. It's much lighter on performance and easier on your system. Next is Disable Camera Update. In this mode, the faces of the splats do not adjust to your view. You can move your Blender camera around, but the Gaussians will look stuck or flat because they aren't being recalculated for your new position, creating spaces which will cause those areas to render as transparent. And then we have Enable Camera Update. This is the live sync mode between Blender and the Gaussian renderer. It tells the plugin to send Blender's viewport camera coordinates to the Gaussian engine in real time. As you rotate your view in Blender, it looks transparent because the faces doesn't rotate. We need to enable the Enable Camera Update, as the faces updates to the active camera alone. This ensures that view looks correct when viewed from the active camera. Now, if we switch to rendered view, you can see the scene we've created, and technically, this isn't traditional geometry. It's made up of splats, basically tiny points that represent the scene. If camera update is disabled, you'll notice the scene doesn't look quite right. Some areas look slightly transparent or broken. That's because the splats faces aren't facing the camera. When use active camera is active, all faces would face the active camera, and there will be no transparency. Viewing from the active camera, we still have some transparency. To fix that, select the low-quality object in the outliner and proceed to turn on, use active camera, so the splats always align with your view. And now, everything looks correct. Before we move into rendering, it's important to reduce your render samples. You can set it as low as 1. Since the lighting and textures are already baked in, there's no need for heavy light calculations. You can also clean up your scene a bit by deleting any points you don't need in a viewport. Now let's move over to the render section in the 3ds add-on. If you just want a single image, click the render button. And if you want to render your full animation, just enable render animation. Now, if you want your camera to follow the exact movement from your original video, head back to the SkySplat add-on. Go to Structure from Motion and click Create Camera Animation. This will recreate the original camera motion, so your Blender camera moves exactly like it did in the footage. Now, one important thing to note, when it's time to render the created scene using the add-on's render engine, EV to be precise, and then use Blender's render engine for any objects we add for VFX. After that, you can composite both together in Blender or other video editing software. If Blender renders your reference video, just go to the Output Properties in the Post-Processing dropdown, untick Sequencer. Now I'm going to add a plane to the scene. This will act as a shadow catcher. Make sure you're using cycles. Then in Object Properties under Visibility, enable Shadow Catcher. This allows the plane to catch shadows from your objects without being visible itself. Next, I'll add an object for VFX, in this case, a cube. Now, if you want to hide parts of your objects behind objects in Splat, you can model a simple rough shape around the object and enable Holdout under Visibility. What this does is cut out that area from the render, making it appear hidden behind your object. Before rendering, choose your output format. Now, when you render using the add-on, Blender might become unresponsive. That's normal. Just let it finish. Once that's done, you can render your VFX objects using Blender's native renderer, in this case cycles, and finally bring everything together in compositing, either inside Blender or in any video editing software you prefer. And just like that, you've taken a real video, turned it into a 3D scene, and built a full VFX shot around it. If you found this video helpful, please subscribe to my channel to see more contents like this. Thanks for watching, enjoy the rest of your day.